Hey guys, welcome back to AlgoYogi. We are doing a two-pointer series. Our next problem in the list is two-sum input array is sorted. Two-sum second. So let's go to LeetCode, and it says given a one-indexed array of integers numbers that is already sorted in non-decreasing order, find two numbers such that they add up to a specific target number. And this is just they're trying to explain how these indexes can occur. So index 1, index 2, starting with index 1. So there is no index 0 this time. But like I don't really care. Like I just need to go through the values, find two numbers that are going to basically give me a sum target, right? So this time, I'm sure you have already done two sum. That's like the first problem anyone and everyone does whenever they start doing LeetCode. So I'm sure you have done it. But if you remember, we were using this extra space hash map where we were storing if the index and the target associated with it, or like current value, target minus current value, and that value is storing the index of that particular value when we are iterating over our array. And then we find that target, and then together they basically make sum equals to target. That's when we return this result of both indices. But what I mean to say is we were using extra space, but this time with two pointers, and when the array is sorted, we don't have to do it that anymore, because now we know this is what we need to find. This is what we need to find, and we can have two pointers, first in the beginning and the second in the end, and only increase depending on if because there is the result will always be there, the solution will always be there. That's why they have told us results are generated such that exactly one solution exists. Now we need to add these two values, these two pointers values, to check if they're equal to target. If not, then we need to make a decision if I am gonna move forward from the beginning or move backward from the back of the array. And that will depend on if my current sum that I'm adding the current two values, two pointers where they're pointing to these two values, if it is greater, then I need to move back. If it is smaller, then I need to move front. Let's understand it on iPad here. So this is what I mean to say. Let's have two pointer. One is gonna be S and the another one is gonna be E. Okay, so what I meant to say, check if S2 plus 15 is equals to 9. It's not. That means what? We're gonna also check if this is greater than or it is smaller than 9. Which one is true? Which one is true? This one is true, right? This one is true. So what's going to happen? We can't basically increment this S, right? Because it will give only bigger values. So what we're going to do is move E backward. So move E to this, and then we're going to check again. But this time also 11 plus 2 is 13. We're trying to find 9, and that's when we will move our E even one index back, and then we just return both of these indexes, right? So we return S and E, and then just that would be our answer. I think that's pretty easy. That will be big of n time complexity and space complexity we have reduced from the normal, the regular two-sum problem to basically constant space. Okay, so I think it's quite easy, I guess. So let's write down the solution. So we can have basically S, and let's make S point to, I'm gonna say 0. You know what? And because they're saying index 1 and everything, so we can just always when we return our answer, we can always increment these two pointers, so that, our result is what they're actually asking us. But remember, indexes of a list in Python, or any other language, they always start at 0. So they're 0 indexed data structure. So, and let's have it like this, pointing to 0 and 0. Sorry, len numbers, and let's say -1. Okay, so for I in range, we're not gonna do that. For we're gonna have while s is lesser than e, if numbers I plus numbers e, numbers s and e, they're adding up to, and I think we can just simply have it called s, or like sum. Let's call it s. S is already there, so maybe like sum val. And let's check if sum val is equals to target. If this is the case, then we just return s plus 1 and e plus 1. Remember that this is only because they are starting the indexes at 1, not 0. elif this is greater than target. That means what? That means we want a smaller value, right, from the end. So e minus equals to 1, else we can just assume that this time the value must have been smaller, because we have already checked if sum val is greater or equals to, so this will be smaller only. So now we can just increment our s. And I am like, because they're saying that this will always exist, then this will always be the case, right? This will always be the case. Then we can just return this -1 here. Doesn't matter. All right, then I think this is it. What else? We can just test it on examples. Works. Let's submit it. Pretty awesome. All right, let's write the time complexity. That will be big of 1, right? And then space complexity big, sorry, oh my god, no, this is not big of 1, this is big of n. I don't know what I was thinking. This is big of 1, Also, I know the problems that the way I'm solving, I'm just writing the most efficient solution, but definitely start because it's a two-sum problem, and they will want you to start with like a brute force approach, which would be using 2 loops, one pointing to the 0, and then another pointing, j pointing to 1. They're trying to add these different values. Whenever they become target, then you just return the answer. Otherwise, then they say you're going to use extra memory, which will be a hash map, that is the regular sum. And then you're like, oh, we can even bring that down because the array is sorted. So we'll have these 2 pointers pointing to the front and back, and then just move them closer so that the value becomes, depending on which one you're moving, the value gets closer to the target, and that's when you basically return the answer. And this is the answer, okay? Let's mark this problem solved. All right, see you guys in the next problem. Bye-bye.